So today we're going to go ahead and talk about inverses. And inverses are something you've actually found before in Math 2, but we're reviewing it here in Math 3. And we're actually extending it a little bit. The extension is going to be really important right here. Before we extend it, we have to understand what a one-to-one function is. So if you remember, a function is where every input, so usually we talk about x values, so for every x value, you only have one y value in return. Okay? So every input, you get only one output. So a one-to-one function is a function. So it's already a function, meaning every input gives us one output. But where every output also maps to one input. Meaning both inputs and outputs are only mapping to one. Let's think about that visually, and then we'll define inverses. So visually, what that means, if we're only mapping to one, let's start with the one input maps to one output. So an input would be like an x value. So here's like a generic x value. If it's mapping to one output, it's only hitting the graph once. But if we're doing outputs are y values. So that's like, this is the y value 5, right? If it's a one-to-one function, we can only map to one single x value. Notice the graph I made, which is a quadratic, is not a one-to-one function. Okay, so this tells us it has to pass the horizontal and vertical line test. So let's talk about now the definition of an inverse. An inverse, by definition, is a reflection over the line y equals x. Okay, so if I had a graph, let's say let's just do another quadratic, even though we know it's not a one-to-one function. If I went ahead and reflected it over the line y equals x, you're going to get a graph that looks kind of like this red graph. Okay, now when it comes to inverses, in order for to get inverse functions, we have to have one-to-one functions. And here's a prime example why. If it's not one-to-one, then when you reflect it over the line y equals x, you end up with an equation that's not a function because it does not pass the vertical line test. Okay, but that's what the inverse is. So the geometric, that's the geometric definition. The algebraic definition is if you take g of f of x, if you have two functions, g of x and f of x, and you set if you input them into each other, you will always, if they are inverses, you will always end up with x. Okay, so that's actually how you verify or refute if they are inverses. You actually do you just insert a composition of functions, that's what it's called. You do a composition of functions and you determine if you get a value of x. So we're going to go ahead and do that. So I'm going to go ahead and do f of g of x. So I'm putting g of x in for x into the f function. And I'm going to go ahead and do 2 times x over 2 minus 9 over 2, and then we have plus 9. And I'll distribute, so I get x minus 9 plus 9, which equals x. Because we end up with x, we know, okay, so this actually is a function. Technically, you're always supposed to check the other way around as well, so I'll show you that really quick. So you get, so we're going to put now 2x plus 9, over 2 minus 9 over 2, which you could split that up as x plus 9 over 2, so 2x over 2 is just x, minus 9 over 2, and that also gives you x. So these two are inverses of each other. So let's go ahead and do our second example. Same thing, if I go ahead and do f of g of x, do I actually get it? So I'm putting g of x in for x. So I have the cube root of x minus 1 cubed plus 1. Now, a common mistake right here is to just say, oh, well, this is just x minus 1. However, that is only true if both the x and the minus 1 are under the cube root. If they are separated, they're considered different terms. And if they're different terms, then we have to actually FOIL and multiply everything out. And we'd have to do it, there would be 3 of these. So since the minus 1 isn't under the cube root, this will not equal x because there's no way that this section's going to equal x minus 1. So we're actually good to go. We know it's not an inverse right away, so we just say not inverses of each other. Even if they look similar, they are not inverses. So that's just a nice way that you can double check that what you've done is an actual inverse.